Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. So this special case of factoring is called the difference of two perfect squares. And some interesting things happen if you have that. But first, the definition here. The difference is subtraction. All right, so we have a subtraction between a couple of algebra terms. Okay, two perfect squares. Well, what's a perfect square? These numbers right here are perfect squares. They come from squaring something. And you can take the square root of them without getting fractions or decimals. So, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on. But these that I circled are perfect square numbers. Notice that also you can do this with algebraic expressions. If I want to square 2x, that's a 2x times another 2x. That actually is 4x squared. You know, you square the 2 and you square the x at the same time. That's a perfect square. You can take the square root of each part. 3y times 3y is 3y squared, quantity squared, and that, of course, is 9y squared. Again, that's an example of a perfect square in algebra. What is 7j quantity squared? Well, that would be 49j squared. And, of course, there are lots of other examples. But everything in green here is an example of perfect square. And if you're going to factor two perfect squares, for example, 4x squared is a perfect square, right? And 9. Let's go ahead and put a 9 right there. All right? So the idea is, how do you factor something that's in that pattern? It's a subtraction between two terms, not three, and each term is a perfect square. Let's take a look at some more examples. To show you how this works, we're going to start backwards. I'm going to already start with a factored expression, two binomials here. And I want you to notice what I have here. I have an x plus 8 and an x minus 8. Just an example we're going to start with. So I have both binomials are exactly the same, the x's and the 8's, but I have a plus in one and a minus in another, positive and negative, or adding and subtracting. Okay, what's interesting is we still get x times x, obviously that would be x squared, and we still are going to get 8 times 8, which is 64. But now let's look at the middle terms. The inside ones, 8 times x is 8x, and the outside ones, x times negative 8 is negative 8x. Now you know that we have to add those middle terms together, and guess what? They cancel each other out. They give you 0. So instead of a three-term answer, which is typical when you what you start with when you're trying to factor, you actually have two, and it's a perfect square and a perfect square and subtraction. Do you see why it's subtraction? Right, we have a positive 8 times a negative 8 gives me a negative 64. Okay, so again, our lesson is looking at this special pattern, which is the difference between perfect squares. So in order to factor from the green to the blue, what we do is we take the square root of each part and we change the signs. All right, let's look at another quick example. So we'll start with the factored expression and see what happens. Notice it's x plus 3, x minus 3. Well, 3 times x is positive 3x. X times negative 3 is negative 3x. Those middle terms would cancel out. That would leave me with the x squared and the 9. Remember, it's 3 times 3. And there is a negative sign or subtraction in between. Difference of two perfect squares. Okay? If I go from this side to this side, that's called factoring. Now I have y minus 4, y plus 4. The only thing different are the signs, right? So these two would give me a negative 4y. These would give me a positive 4y. They would cancel out. No middle term. And the result would be y squared minus 16, a difference of perfect squares. So I would factor that as y minus 4, y plus 4. All right, if I start with j minus 10, j plus 10, as you've seen, I have a negative 10j and a positive 10j. Those cancel each other out. So I'm left with j squared minus 100. A difference between two perfect squares, and they would be factored like that. All right, now it gets a little more complicated than that, but let's try some examples. Take a look at 21 and 23, and notice how they are a difference of two perfect squares. Go ahead and pause the video and see if you can factor that. All right, so first thing I notice is that I need to double check that it fits the pattern. N squared is my first term. Is that a perfect square? Yes. So I know that I can take the square root and put it in both places, an n and an n. And it says minus 1. Well, just focus on the 1. Is that a perfect square? Can I take the square root of it? Yes. So I'd have a 1 there and a 1 there. And the pattern, again, is it's plus minus. Doesn't matter which is which, but one is negative, one is positive. Now, if I was to multiply that out with the FOIL method, the middle terms would drop out, and that is my factored answer. Okay? Hopefully you've got this one. What's the square root of 25x squared? 5 and an x. Yep, put a 5x in each place. Square root of 1 is 1, and it's a plus minus pattern. Use FOIL to double check yourself if you're not sure, and that middle term would drop out. So that's how you factor 25x squared minus 1. And go ahead and try these two examples, write it down on paper, and then replay the video. All right, again, do those fit the pattern of having a difference of two perfect squares? Yes, because you can take the square root of 16x squared, that would be 4x in both places, and a 1 is again a perfect square, that's 1 times 1, and the pattern is plus minus or minus plus, doesn't matter which order. All right, again, the only way to make that work is to have the middle terms drop out, and that's how you factor that one. Number 28. It'd be 5x and 5x. When I multiply, that would give me 25x squared. Is 9 a perfect square number? Yep, that would be 3 and 3, and a plus and a minus. All right, good luck, and I'm glad you watched the video. Thanks. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.